Buongiorno a tutti. Good day to everyone. This is video number 2 on the endocannabinoid system, and I strongly suggest that you watch video 1 before this one because I'm going to assume a little bit of understanding from that video. I will review, and then we'll go on to talk about endocannabinoid system in your immune system, in your gut, and we'll talk about CBD. But I need to know that you understand the lock and key model of chemical messaging inside your brain and inside your body. So let's start there. So chemical messages are small substances with particular shapes. Here shown dopamine as a red triangle, glutamate as a blue square, and GABA as a green oval. Of course, this is a metaphor and a cartoon, but they fit like keys into locks called receptors, and when they do that, they send a signal of some kind. Same in your endocannabinoid system. We'll see that in a moment. So dopamine fits into its dopamine receptor, but not the glutamate receptor. Vice versa, glutamate fits only into its receptor, and GABA into its receptor. Ignore the C for now. Each time they fit in, there's a signal. If you look only at the right, at the big purple rectangle, you'll see the endocannabinoid system. There are 2 chemical messages, the endocannabinoids 2-AG and anandamide, which we discussed at length in video 1. And there are also 2 endocannabinoid receptors, 1 and 2. You'll see 2 is a little smaller than 1, but they both have the same general shape. And so both 2-AG and anandamide, or AEA as it's also called, fit into both the endocannabinoid receptors 1 and 2, and they send a message through both receptors. Before I show you a review cartoon of what we did in the brain with the endocannabinoid system, which will give us a real good jumping off place to talk about the rest of it, I'm going to tell you that I included 2-AG in this cartoon. It's the second well-known endocannabinoid chemical message, in addition to anandamide, or AEA, which we discussed before. 2-AG stands for 2-arachidonyl glycerol. It's insane. We know the names are out there, so just forget them. It's anandamide and 2-AG for us. And they both stick like keys and locks to the endocannabinoid receptors. Number 1, mostly in the brain. Number 2, mostly elsewhere than the brain. In the brain, at the top center, a little cartoon representation for the endocannabinoid chemical message 2-AG. I've used that in this in addition to anandamide. Top 2 pairs of nerve cells send the chemical message GABA from the left hand to the right hand nerve cell, which has a receptor for GABA. GABA sends an inhibitory signal in that case. The bottom pair of nerve cells uses the chemical message glutamate, which sends an excitatory signal to its receptor on the right hand nerve cell. In each case, endocannabinoid chemical messages are sent backward, bind to their receptor number 1 in the brain, and sending a signal backward. One more point to review: THC fits into your endocannabinoid receptors like a slightly defective key in a lock. It opens the lock, but not completely. So it does send a signal through your endocannabinoid receptors 1 and 2, but not as strong or effective a signal as your endocannabinoids anandamide and 2-AG. How can a lock be opened only part way by a key? Remember, this is not mechanics, it's molecular biology, and anything is possible. The second point is that why? What's it doing? Well, in the brain, it's probably doing something to improve the functionality of the synapses or synapses between your nerve cells. It's 600 million years old evolutionarily, and it wouldn't have stayed around this long if it didn't have a constructive function in your brain. What exactly that is still in doubt, and what THC is doing acting in there, well, that's still in doubt too, but a lot of people find that it's doing a lot of positive things for them. Okay, final summary of the system. Endocannabinoid chemical messages in purple, upper left, anandamide or AEA and 2AG. There's also PEA and possibly several other endocannabinoid chemical messages. Receptors in blue on the upper right. Receptor 1, ECR1, and receptor 2, ECR2. Also TRPV1, also known as vanilloid receptor, and sensitive to the drug capsaicin. And then GPR55, an orphan receptor, which seems to be, both of those seem to be involved in inflammation in the endocannabinoid system. Finally, the phytocannabinoids on the lower left, there's your list. Various THC compounds, CBD compounds, and at least 60 other phytocannabinoids in the plants, in addition to terpenes, which are bioactive, but we don't have time to discuss them in this video. So, to reiterate, we're studying the cannabinoid system outside the brain, mostly in the immune system, because that's where it's best understood outside the brain, right at the moment, at this point in 2019. Now, the immune system, like the brain, consists of communicating cells, millions of them. Inside the brain, cells communicate by chemical messages, as we've seen, glutamate, GABA, dopamine, serotonin. The chemical messages in the immune system, in addition to the kind of normal hormones, those chemical messages are called cytokines. And a lot of them are known as interleukins because they carry messages between leukocytes, the other name for white blood cells. Interleukins, between white blood cell messages. Chemical messages of cytokines, there's probably 50 or more cytokines, and they communicate differently than in the brain because the brain, those hundreds of millions or billion cells are all together in the skull. And the immune system goes throughout your blood. White blood cells circulate to all different tissues, your muscles, your digestive system, your respiratory system, and most of them can be found in your digestive system. About 70% is the estimate. And so we're going to come back to that. So millions of different white blood cells. There's about 15 or 20 maybe different types of white blood cells in the immune system. And they're all communicating by cytokine chemical messages. So most importantly, from our perspective, most white blood cells or leukocytes, the different ones of the immune system, have endocannabinoid receptors, mostly receptor 2, and lots of them make anandamide and AEA and send them as endocannabinoid chemical messages. And this is over and above the cytokine network that controls those cells. And THC is going to have effects on your immune system because THC, you remember, is a partial lock opener. It partially binds to the receptors endocannabinoid 1 and 2. So your endocannabinoid system itself is affecting your immune system, and phytocannabinoids like THC are going to affect your immune system. CBD as well, but not exactly in the same way. Briefly survey some of the different white blood cells or leukocytes within your immune system. You've got macrophages and antigen-presenting cells, APC. These trigger a lot of immune responses. You've got microglia, which are macrophage-like cells in the brain. And this is another way for your endocannabinoid system to affect your brain through these immune cells. You've got Th cells or helper T cells, which for specific immune responses are the regulators of those. You've got TC cells or cytotoxic T cells, which can kill viral infected cells. Certain conditions can kill cancer cells. You've got B cells that make antibodies. You've got neutrophils that use these antibodies in search and destroy missions against bacteria and other parasites. You've got mast cells and basophils, which provoke inflammation. And it's important to note that inflammation provoked by the immune system is normal and constructive if it's short-lived or acute. If it's chronic, if it goes on and on, it's generally destructive. Bottom line, it looks like your endocannabinoid system using anandamide, 2AG, and mostly receptor number 2, but sometimes number 1, is a modulator of your immune system. If you look at that network of communication among the cells, the different white blood cells of your immune system, these cytokines by which they communicate with one another, A paper I've read thinks that the endocannabinoid system is a master regulator of that whole mess. That whole network of communication is somehow regulated by the endocannabinoid system and maybe smoothed out. Maybe in chronic inflammatory diseases by which your immune system shouldn't be causing inflammation, like MS, multiple sclerosis, other autoimmune pathologies maybe, like Alzheimer's disease and Lewy body dementia, like chronic inflammation in your gut, ulcerative colitis, and Crohn's disease. And these seem to be responsive to THC and CBD, the phytocannabinoids, which supports the idea that your endocannabinoid system is involved in these. Final piece is your gut bacteria. 70% of your immune system mostly hangs out in your gut, where most of foreign organisms, viruses, and bacteria enter. But you have gut bacteria that are important to your digestion, your nutrition, and other physiology in your body. Some of these gut bacteria are good. They make vitamin K and vitamin D, for example, other functions, and some of them can still be pathological. How does the immune system, which is inclined to kill all foreign organisms, distinguish between leaving the good ones alone and getting rid of or limiting the growth of the bad bacteria in your gut? Turns out that the endocannabinoid system may help it distinguish between the good and bad bacteria in your gut microbiome. One last time with this bloody cartoon. Over to the right, look at the endocannabinoid receptor 1. CBD sticks to that receptor, but it's not like a key in a lock as THC or your endocannabinoids do. CBD sticks to that receptor in a different way and is thought to somewhat inhibit that receptor's sensitivity to THC and your endocannabinoids. More importantly, CBD also facilitates the function of anandamide, of your own endocannabinoid anandamide, by a mechanism that's similar to what Prozac does in your serotonin system. Even more importantly, CBD sticks to other receptors in your brain. Not like a key in a lock, but it has an influence on them. The GABA receptor sticks to CBD, which may have something to do with CAD's anti-seizure activity. The dopamine and serotonin receptors also. So CBD on this basis is called promiscuous. It's called the promiscuous phytocannabinoid because there's so many receptors that it sticks to and influences. So here we are with more research being needed. Because of CBD's promiscuity and sticking to all of these different receptors, the mechanism of action overall in your body of CBD is extremely complex and it needs more study. Federal government, again, get it the hell off Schedule 1. We need research. Okay, that's enough for now. I hope that this video was helpful to you. Have a good day, and I will see you again soon.